Here we are at problem 7a from our target 3. We're asked to complete the following marginal distribution table. Now, in just looking at our distribution table, we notice that we are looking at hair colors for males and females. And in this category, we notice the females and their corresponding hair color. And likewise, the male, we're actually missing some. Now, there is some information to be able to help us out, though, in identifying maybe what some of these missing blanks are. Now, the fun thing about marginal distribution tables, or these two-way tables, is that they kind of work a lot like those Sudoku games. So if you've ever played one of those, it's very, very, very similar to that kind of idea here. Now, when we're looking at the male with blonde hair, right now we know that there are 9 females with blonde hair, and that the total is going to be 14 for this row of people with blonde hair. So then that forces that there has to be 5 males that have that blonde hair. Now going ahead and looking then at, let's say, the total for just even males. Well, we know that there are 5 males that have blonde hair, 16 that have brown hair, then that forces that there are 21 just males in general. We would just add going down. Likewise, we can just add the people going that have our brown hair. So there are 17 females that have brown hair, 16 males. And so we should end up then with a total of 33 people that have brown hair. Now going ahead, and you can either go down or to the right to get the total people. That's brown hair or blonde hair or males and females, because again, this represents all the people in this particular study, and we would end up then with a total of 47. Now, when we're looking at the marginal distribution, all we have to do is pretty much, it's very similar to our relative frequency tables, where we just take the total for each individual item. So in this case, for the blonde hair, we have 14 divided by our total of the total count, so ending up with 47. And when we do that, we end up with a decimal of 0.297. In which case, we're then going to round this up to 0. Well, this guy would actually get rounded, this 9, to a 10. In which case, then it would affect this value as well. So we would actually round this entire thing up to 0.30. Because again, we look at the 1,000th place to round this 100th place. Since he is more than 5, we can go ahead and round then this 9 up. And so when we're rounded, it comes out to be 0.30. The other one, brown hair, we end up with 33 over 47, which comes out to be about 0.702. In which case, when we round again, because of our 1,000th place, we're going to round our 100th. But because it's under 5, it actually just stays 0.70. You didn't have to round up there at all. Now going ahead and looking at our marginal distribution for our females. So again, just looking at the females, we have a total of 26 out of 47. In which case we end up with a decimal value of 0.553 or just 0.55. Because we're again looking at that 1,000th place to round that 100th. Then also looking at the males, we have 21 males out of 47. We end up with a decimal value of 0.446. And because we are looking at our 1,000th place to round our 100th, it is more than 5, so we are going to have to round this up to 0.45. And we'll get rid of this 1,000. Now looking at our totals, what we'll end up doing is adding our marginal distribution. So 0.55 plus 0.45 comes out to be a clean even 1. So again, those were just looking at both female and male. We ended up with those marginal distributions totaling 1. Whereas when we look at our brown hair and blonde hair, we have 0.30 plus 0.70, we do also end up with a clean 1. So those total marginal distributions end out actually becoming the same. Again though, that is problem 7a from our target 3.